could work with you offshoot to get caught up with something else.
All right, I'm gonna share my screen. Happy Thursday, everybody. The links are in the chat. The links are in the chat, and away we go. All right, let me adjust all this. Got to get my Zoom settings all straightened out. There we go. Independent living, section 2, reading a floor plan, Friday, May 27th. All right, here it goes. We have our 3 learning targets. There's the 1. I can compute the perimeter and area of a polygon. We did that Monday and Tuesday. And Wednesday, we even did something. If you didn't do the Wednesday work already, it's example 3. There's a video out there. We're also going to start taking a look at computing the areas of irregular regions. I'll show you how to do that by the end of the week. And I can compute the volumes of rectangular solids. That's for Friday. All right, I think we're doing irregular regions today, actually. So if you're on here, you already should have your name and learning targets in there. If you started this yet, we've already done this warm up, that warm up. Let's do 2 more. Let's do 2 more warm ups. This one right here, warm up. A rectangle has a length of 24 feet and a width of 14 feet. What is the area of the rectangle?
What do you do with those 2 numbers? What do you do with there? Area equals length times width, right?
Area of a rectangle is length times width.
So what do you do?
Izzy Omari, hit me up in the chat.
You've already doing it? It's length, it is length times width. So if this room, let me give you a hypothetical. If this room was 10 by 10, it's 10 times 10, which is 100. So if they give you the width and the length, what do you do with those 2 numbers?
You got it.
Just do it. That's your answer.
There's my very ugly rectangle.
Well, when you say square,
Mhm.
feet squared, meter squared, something squared, because you squared it, you put in the square. Did you hear him? No? Are you hearing? Okay. Multiply.
All right, 24 feet, 24 feet long, 14 feet wide. It was 14 feet, wasn't it?
Yeah.
All right. So the area of a rectangle is the length times the width, right? We often look at it, it'll look like capital A equals, and we'll have like a little cursive L, length, and then they'll have little times, lowercase w. Area equals length times width, which means the area will equal, in this case, 24 times 14. Anybody got it for me?
If you can't put the subscript or superscript.
That sounds about right. 336 feet squared, right?
If you
336
can't
feet
spell it, you
squared.
can still spell out square feet.
Mhm.
Square feet. So you could just spell square feet, because that's the same.
So I'll show you the 2 different ways. So we say 360. 360. You can do 2 different ways. You can do feet. 336. Oh, my bad. I need a right eraser. 336. I'm told. $336. All right, I'll stop sharing here. I'll get rid of this. We're sharing. Oh, I forgot to reshare my screen. Here we go. So there's 2 different ways. It's gonna be 24 times 14 is gonna be equal to area. And we already was told it was 336. But sometimes seeing is believing with these things. 24 times 14. Oops, and I have 2 multiplications, and the calculator is going to have a conniption over having 2 multiplication signs. Right, 336, just like we were told. 336, and there's 2 different ways. You can do feet caret 2 as feet squared, like that. Alternatively, you can just do 336, and you can do SQ dot FT, however you like to do it. Both are perfectly legit. Or if you actually want to write it out square feet, you can write it out square feet as well. 336 squared feet, or you can say feet squared in letters, right? You can also use words. Most commonly, it's one of these two though. Most commonly, the abbreviation is the case. All right, one more warm up to get us thinking. A rectangular prism. I don't know if you ever realized this, but in math, when you have like a box, okay, a box, we call that a rectangular prism, right? The idea is a rectangular prism is a three-dimensional shape composed of rectangles. That's why it's a rectangular prism. That's the technical math term for a box, right? Or a cube or something like that. These are rectangular prisms. All right, a rectangular prism has a three-dimensional shape with length, width, and height. You would find the volume of such a shape by multiplying the length times the width times the height. So let's think about this one. Actually, you know what? We'll leave this for Friday, actually. We'll leave this for Friday because then we have two to do on Friday. All right, we'll skip it.
Isn't the rectangular prism
Length times width times height.
plus length times width plus what do you square that? Plus width times height plus length times height? Like, isn't it? Because the prism, it's not, it shouldn't just be the bottom, right?
To calculate the volume of rectangular prism, it should just be the length times the width times the height.
Unless I'm thinking of something.
Think about, let's think about a 2 by 2 by 2 cube, right? So if it was 2 by 2 by 2, we'd have 4 on the top, on the top layer. We'd have 4 on the bottom, right? So we'd have 8 cubes altogether. 4 plus 4 is 8. And then if we do 2 times 2 times 2, we have 8. That's how I think of these things. All right. So great. So we've already done day one, example one. We did this on Monday. There's a video here if you missed it. We did example 2 here on Tuesday. There's a video there if you missed it. There's the video. And then this is what I had you do on Wednesday. I'll just talk about it. The gazebo problem. There's a video there that I did up on Wednesday. What's that? This is a picture of a gazebo. There's the video for the gazebo problem. So they want to build a gazebo, but the thing about a gazebo is it's an odd shape. This shape here is called an octagon, an 8-sided shape, right? So you have to use a special kind of formula to find out the area of an octagon. And here's how you do it with any kind of regular polygon. Any regular polygon. What's a regular polygon? Let's start with a polygon. A polygon is a flat, two-dimensional shape with many sides. That's a polygon, right? Technically, I suppose a triangle is a polygon, a square is a polygon, but usually we talk about polygons in terms of pentagons, octagons, dodecahedrons, like these kind of gons. So these kinds of shapes here we usually refer to as polygons. All right. Then there are these things called regular polygons. Now a regular polygon has all the sides have the same length. All right. So this is a regular octagon, which tells us that each one of these sides is exactly the same. So if you know that this one side is 10, that means you know this is 10, and that's 10, and that's 10, and that's 10, and so on. All right. That's what a regular polygon is. Okay. And there's this thing you probably have never heard of yet. I don't know. Have you guys ever heard of an apothegm? An apothegm? Right? You're only if you would only know this word if you took geometry. Right? An apothegm is the line that goes from the center of a regular polygon to one of the sides perpendicularly, which means at a 90-degree angle. So the apothegm would be any line drawn from the center of the polygon, which is here, to one of the sides hitting it perpendicular. So there's actually, you could draw 8 different apothegms on this shape because it has 8 different sides. You could draw a line from the center 90 degrees to the side as well. But all you need is one apothegm length. Once you know the length of one apothegm, you know what the length of them all. And then you'd have to use this special formula here. Area is going to equal 1/2 times the apothegm times the perimeter. All right, so this is what we learned on example 3. There's a video about it. To find the area of this particular regular octagon, we're going to take 1/2 times the apothegm, which is 12, times the perimeter. The perimeter is going to be 80, right? Because if this side is 10 and we have 8 sides, if I add up 10 8 times, I'm going to get 80. So my perimeter is 80. 1/2 times 12, my apothegm, times 80 gives me 480 feet. The area of this this regular octagon is 480 square feet. Okay, that's what we did for Wednesday. This is what we're doing today. To me, this is cool. This example is pretty neat to like think about this, because when I was in high school, I had no idea. No one ever showed me how to do this before. I didn't know this till after I got out of college. We're going to use the Monte Carlo method for determining the area of irregular shapes. Here's how we're going to do it. Here's the example. Don sculpts out a region for a flower garden, as shown. So this irregular shape here, it's called a freeform. What's that? Freeform. I forget what they call these. Freeform plane figure. Yeah, that's what it is. So this is called a freeform plane figure, which means it just has lots of curviness to it, right? It's not a regular shape. It has an irregular region. So he wants a flower garden. He's not going to have it nice and neat. He wants it kind of natural. He wants it kind of curvy. So he takes a digital picture of the garden. He goes, maybe gets a drone, goes up high, takes a picture from above. And so that gives him an idea of what the border of his garden is, which he can just kind of draw on top of the picture to find out what the border is. And then he just measures he's going to take this irregular region. He knows that would fit inside of a rectangle that's 15 by 20. So he's going to take that picture. He's going to kind of trace this outline. And then he's going to say, hey, this entire garden will fit inside of a rectangle that has a width of 15 and has a length of 20. Okay, so a length of 20, a width of 15. He then superimposes a 15 by 20 grid over the photo on his computer. The area of the garden impacts the cost of mulch, fertilizer, and so on. What is the area of the garden? So the reason why we might want to know what the area of some kind of this free-form plane figure would be is because especially if the garden was huge, if this garden was huge, you would actually want to know how much fertilizer am I going to buy exactly? How much grass seed do I need? How much mulch do I need exactly? And to calculate those things, you're going to need to have an idea of the area you're talking about. The bigger the area, the more you're going to spend, which means the more you're going to actually want to get an exact figure. If this was a small garden the size of a desk, you probably wouldn't need to mess with it. 2 bags of mulch, that'll be fine, right? And then if you have some extra mulch, it's no big deal. When you're spending $10,000 on mulch, you want to know exactly how much you're going to need. You don't want to spend an extra 1,000 more than you need. Okay, so this garden is not a polygon. It is a free form plane figure. All right, Don can use probability to find the area. First, he'll frame the irregular region with a 15 by 20 rectangle, which he's already done, whose area is 300 square units. Now, so the usefulness of what he's doing here, he's saying, hey, I can figure out the area of this rectangle. That's not hard. 20, I know the area of rectangle is the length times the width. So 20 times 15 is going to give me the area of my total rectangle. Oh, I did 20 times 14. That's not what I wanted. 20 times 15. This is the area of the total rectangle, 300 square units. Yeah, we just have units here. We don't have feet or miles or whatever. So 300 square units, that's the rectangle's area. Then if you were to, and this is where it gets clever, if you were to generate 1,000 random points, if you were just to like go dot, 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 just random dots all over this figure, and then you were to count up, how many of those dots landed inside the garden and how many of those dots landed outside the garden, you would get an idea of what proportion this garden takes up inside that rectangle. And once you know that, you can use that proportion to subtract the garden from the rectangle, which gives you the rectangle. All right, so he generates 1,000 random points. He says he's going to say that the domain is 0 to 20, right? Because the domain could be anywhere from where x is 0 to where x is 20. That's the grid that he's got going on here. He said that the range could be anywhere from 0 to 15. Why are we talking about this? It's because your calculator can actually generate for you random points if you give them the range and domain for what they need, the calculator needs. So most graphing calculators have a random number feature that can generate the x and y values of the problem. Don plots the points, and he determines that the number of points that landed inside the garden, he finds 631 points landed inside the garden region. He uses the following proportion. So here's a portion he's going to use. He's going to say, hey, the number of points inside the region divided by the total number of random points is going to end up equaling the area of the irregular region divided by the total area used to frame the irregular region. So the number of points inside the garden divided by the total number of points inside the rectangle is going to be the same proportion as the area of the irregular region divided by the area of the rectangle. So he sets it up like this, right? 631. That's how many points landed inside the garden. Divided by 1,000. That's how many random points are in the rectangle altogether. He just decided he's going to have 1,000 random points. That should equal the unknown number we don't know. What we don't know is the area of the irregular region. That's going to give that an X. Divided by 300. That's the area of the rectangle that we do know. So 631 divided by 1,000 should equal X divided by 300. We're just going to solve for X, right? We do the cross multiplication. X times 1,000 is going to be 1,000 times X. 631 times 300 is going to be 189,300. And we'll just divide by 1,000 on each side of the equation to get X by itself. You guys are actually getting pretty good at solving these simple linears. So what we get as a result is that X equals 189.3. That gives us an idea that the area of this free-form garden should be approximately 189 square feet. And again, what's neat about this is that because you can't actually calculate and measure the actual area, you could actually estimate. You could say, okay, that's a full unit. That's a full unit. That's about a half a unit. And you could just kind of start counting up boxes and kind of get one estimate that way. Just by trying to estimate, maybe that's a third of a box. Maybe this one here is a fourth of a box or something. But the problem with that is it's not exact. This 1,000 random positions, gives you a pretty good statistical spread to say, hey, if you legitimately have 1,000 random dots inside this rectangle, and if 631 of them ended up to be inside the garden, then that should give you a pretty good idea of the proportion of the garden to the area of the rectangle. And if we were to actually do that, 631 divided by 1,000, we could find out a percentage. All right, 631. So that's about 63%. About 63% of our rectangle, and that makes a little bit of sense there. If you just look at that garden, you'd say, you know what? That garden is a little bit over half the size. If I was to split this rectangle in half, this garden would fill up exactly, 1/2 or more. And that's what that 63% is telling us there. This garden is a little bit bigger than 50% of the whole space. All right. So the area, so this method is called the Monte Carlo method. It is based on probability. The theory that the ratio of points that land inside the region to the total number of points should equal the ratio of the area of the irregular region to the area of the rectangle. The more points you use, the more accurate your approximation. So he used 1,000 points. That's great. That gives a pretty good picture. If he was to use 30 points, that wouldn't be enough. 30 random points. There's not enough. How do I say this without getting too much into probability and statistics? And there's not enough sampling there. It's insufficient sample space to get a good prediction. But 100,000 points would give me an even better number. All right. Here we go. Here's I'm going to do this one with you, and then you're going to do 2 more. An irregular plane figure is framed inside of a 20 by 20 square that represents a 20-foot by 20-foot square. To find the area of the irregular plane figure, 2,000 random points are generated, and 910 of them land inside the irregular region. What is the area of the irregular region to the nearest integer? Okay, let me give you just a minute or two to work on that.